Okay, I'd like to talk today about the limit of a function. The limit of a function or an expression is where the function or expression's value is had as the variable approaches a certain value. It's quite often the function value, okay, but not always. If you see limit such and such as x approaches some number and then you see a superscript of negative, it means approach from the negative side, the left. If it says to approach from the right, if you have a superscript of a plus, it means from the right. So you follow from the positive side, okay, the right. If you don't see a superscript, it's just x approaches that number, then what you're doing is it has to be the same from both directions, okay? So for instance, the limit here, these two are approaching 3 from both sides. The limit here would be 3. This one, since the limit approaches, and since this is approaching 2 from this direction, it's approaching 1 from this direction, the limit there would not be a single limit there. We will do both of those in detail, okay? So, here's the function I started with. It's a piecewise function. You don't need to worry about graphing it. The graph is provided. Okay? If I want to know what f of 4 is, well, I just go to x equals 4 on the x-axis, and I go up, and I see that it most closely matches the 2. Okay? So, I go to x equals 4, y equals 2. Okay, function value is 2. What is the limit as x approaches 4 from the left? Okay, there's a superscript of a negative up here. So I will approach x equals 4 from the negative side. And here's where x equals 4. If I approach from the left, the function value is head to 2. This one says to approach from the right. Okay, so here's where x equals 4. I'm going to approach, it says approach from the right, so I'm going to start from the right and go until I get to x equals 4 from the right. And the function value is head to 2. Okay, now what is the limit? The limit as x approaches 4. Well, from the left, here's where x equals 4. From the left, the function value is head 2. From the right, the function value is also head 2. It's the same both directions, so it's again 2. Okay? The next question, next group, E, find f of 2. Well, I go to where x equals 2, and there's an open dot right above 2. Does not exist. Okay? So there's an open dot over 2, which means the function doesn't exist at that point. Okay? It's not defined at this point. So, as a consequence, there's no function value there. But that's a different question from the limit. Okay? The limit from the left. Well, I'm approaching x equals 2 from the left. So follow. Looks like it's head to 3. Function value is head to 3. Now we want to approach from the right. X equals 2 from the right. So I follow from the right. And once I get to x equals 2, the function value is head towards 3. It never reaches 3, but that's where it's headed. That makes it the limit. Well, find the limit as x approaches 2. Well, I approach from the left. Function value is head to 3. I approach from the right. The function value is head to 3. Well, it's the same both directions, so the limit is 3. Now, let me talk about another case involving limits of 6. Okay? So let me add I. Limit as x approaches 6 of f of x. Let's say, let's start by approaching from the left again. So as I approach from the left, Okay? Follow, 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 follow. The function value is head to 1 from the left. Next, limit as x approaches 6 from the right of f of x. Okay, as x approaches 6 from the right. Okay, that's a plus. So I'm going to approach from the right, and it looks like the function value is headed to 2. Okay? K, what's the limit as x approaches 6 of f of x? Okay? So as we approach x equals 6 from the left, x equals 6, or the limit is 1. As we approach from the right, it's x equals 2. Answer: does not exist. Okay? Since the limit was different depending on which direction we approached from, we approach from the left, it's 6. We approach from the right, it's 2. As we approach from the left, it's 1. As we approach from the right, it's 2. It's different. So the limits are not the same for both directions. So the limit as x approaches 6 doesn't exist. Okay? So to recap, in the case of x equals 4, the function value of f of 4 was equivalent to the limit from both directions. That happens, okay? That's usually the case, to be honest, except in problems made for purposes of teaching the limits. Now, f of 2 doesn't exist, okay? It's an open dot. There's no function value there. But the limit from the left, we approach from the left, it's head to 3. The function value is head to 3. So we approach from the right, it's approaching x equals 3. Okay, or sorry, it's approaching a function value of 3. So the limit here is 2. Sorry, the limit of x as x approaches 2 is 3. Okay? For 6, as we approach from the left, it's 6, and it's 1. As we approach 6 from the left, it's 1. As we approach 6 from the right, it's 2. So the limits are different depending on direction. So there is no the limit. All right. I'll be doing additional examples to try to make this clearer. All right. Let's talk about this function. No rule that I know would provide a graph that looks like this. So don't worry about what plugged in to get this because I don't know of anything. Okay, so the limit as x approaches -1 from the left side is 1. Okay? Okay? As we follow up, the function values head to 1. As we approach -1 from the right, the function value is also headed to 1. What is the limit as x approaches -1? Well, from the left, it's 1. From the right, it's 1. So it's 1 from both directions. So the limit, as x approaches -1, the limit is 1. Okay, because that's where the function value is headed as we approach from both directions. All right, f of 3. I'll go to where x equals 3 on the number line, and the matching y is 1. What's the limit as x approaches 3? Well, if I follow the function value towards x equals 3, from the left, it's head to 1. As I follow it from the right, it's also 1. Okay? So since the limit from both directions is 1, from both directions, that's the limit as x approaches 3. Notice it was the same as the function value. Now let's talk about the limit as x approaches 2. Well, if I approach from the left, I'm headed to function value 4. As I approach from the right, I'm also headed to function value 4. So since we follow the function to x equals 2, as we approach from the left, it's 4. As we approach from the right, it's 4. It's the same both ways, so it's 4. But the actual function value is 6. There's a closed dot over top of the 2. So the function value as x equals 2 is actually 6. So the limit and the function value were different. Okay? Next, let's talk about the limit as x approaches 5. The limit. Well, if I approach from the left, I'm headed to 1. Function value 1. But if I follow from the right, I'm headed to function value. If I follow from the right, I'm headed to function value 2. Since the limit from the left is 1, the limit from the right is 2. They're different. So this is not, or so the limit does not exist. Quite often abbreviated DNE. So I'm going to find the limit as x approaches 1. So here's where x equals 1. If I approach from the left, I get 3. I'm headed to function value 3. If I approach from the right, I'm also headed to function value 3. Okay? Now, the next question asks, what is f of 1? Well, if I go to x equals 1 on the graph, well, the function value is defined, and it's 3. Okay? Now, here's something else I didn't discuss, and that's something called continuity. Where is f of x continuous? All right? Well, it's continuous from negative infinity until negative 1, but not including negative 1. And it's continuous from negative 1 until x equals 2. This doesn't ask where is it defined. It asks where does it have no breaks, no gaps, no funny business. Okay? No holes. Okay? And then it's continuous, again, from 2 to 5. And then it's continuous after 5. Okay? That's interval notation. Others might say all real numbers with the exception of x does not equal negative 1, 2, or 5. All right, that's it for this problem. Okay, I have switched classrooms. We're going to stop doing graphing problems and we're going to start doing algebraic expressions. Some reminders. The limit is where a function or expression's value is headed as the variable approaches a specific value. Okay? The limit as x approaches c of f of x is often f of c, but not always. We saw that in a previous example. And the limit may exist even where the function value does not. We saw that in the previous example as well. In algebraic expressions, which is what we're switching to, you first simplify the expression as it's doable, as simplification can be done. Then and only then, you plug the value in. Okay? Simplify the expression, then plug it in. Don't plug it in until the simplifications are done. Okay, so example 3, I want the limit of f of x equals x to the 4th minus 9x plus 8. To find the limits of this function, this cannot be simplified to my knowledge. So I'm just simply going to plug in negative 5. Like so. Okay? Well, negative 5 to the fourth is positive 625. Because any negative number to an even power is going to be positive. Plus 45 plus 8. This is 678. Okay? So the limit of this function as it approaches negative 5 is 678. That's also its function value. Okay? Now, for this one, I want f of 13. So, f of 13 would equal 13 squared minus 10 times 13 minus 39 over 13 minus 13. Okay? You may already see the problem here, but I'll keep going. This is 169 minus 130 minus 39 over 0. This does not exist. Division by 0 does not exist. Now, let's talk about something else. Let's say I want the limit of this function as x approaches 13. Well, the first thing I have to do is I have to simplify this. The top factors as x and x. Two factors of negative 39 down to negative 10 are positive 3 and negative 13. Oh, and over x minus 13. These x minus 13s will cancel, and this will just leave me x plus 3. Now, having simplified the expression, I will now plug in the 13. At x equals 13, we have 13 plus 3, which is 16. Okay? So the limit of this function as it approaches 13 is 16. But the function value itself doesn't exist. Okay? I'm going to pause this and put a few more examples on the board. All right, sometimes they'll just have the limit of the expression. Okay? Well, there's no function name here, and this time they're using t's. Well, that's fine. We'll follow the same procedure. There's no simplification I know that can be done here, so we'll simply start plugging the numbers in. Okay? So, that's 1,000. 10 squared is 100 times 12 minus 1,200 plus 1. Well, that's going to be negative 199. All right. This problem, well, first we need to simplify the expression. That can be writable as x plus 14. This is a difference of squares. It's the square root of x squared is x, square root of 196 is 14. So x plus 14, x minus 14. And these x plus 14s cancel, leaving me 1 up here. So I have 1 over x minus 14. I'm going to rewrite that 1 so it's a little neater. All right. Now, at x equals negative 14, we have 1 over negative 14 minus 14, which leaves me 1 over negative 28, which is writable as negative 1/28. Okay? All right. I'm going to close this and put another example on the board. Okay. Now, this is the type of problem that tends to intimidate students more than it needs to. So let me go ahead and explain to you what you want to do in this type of problem. You're going to want to simplify just this part first. Okay? Steps 1 through 3. Simplify just f of x plus h minus f of x over h. You'll just do that. Okay? So step 1, simplify f of x plus h only. Okay? Step 2, subtract the original f of x. Okay? All terms in f of x cancel. Okay? And only remaining terms, okay, only the, let's see, all remaining terms, why don't I rephrase it that way? All remaining terms have h. Okay, after this step is over, all the terms in f of x would cancel against the counterpart, and the only surviving terms would have h's in them. 3, divide off the h. Okay? And then step 4. After simplification, let h equal 0 and simplify. All right. I am now going, so remember, you are simplifying an expression first, and then you will plug in that value for h. Okay, that variable in for the variable. So that value in for the variable. So, in this case, you're going to be plugging 0 in for h, not x. Okay? And I'm going to go ahead and move this table over so that you can see all this, so that you can see this more clearly. Okay, so here it goes. First, f of x plus h equals 35 times x plus h squared plus 19. Okay, now this doesn't all have to be done in one step. So I propose to do some scratch work over here. X plus h squared is equivalent to x plus h times x plus h. Okay? Which gives me f, o, I, and l, if we use the FOIL method, x squared plus hx plus another hx plus h squared. And this combines into 2hx's. X squared plus 2hx plus h squared. Okay? So, when this is all said and done, it is 35 times x squared plus 2hx plus h squared plus 19. Distribute, and I have 35x squared plus 70 hx plus 70 hx plus 35h squared. Yeah, it's going to need to be written more clearly. Plus 19. Okay? Second, we've done this part, now we'll do this part. So we'll be subtracting 35x squared plus 19. Okay? So the 35x squared is going to, and as we said, when we get to this point, all terms in the f of x will cancel against counterparts. So 35x squared is being subtracted from 35x squared. That'll cancel. 19 is being subtracted from 19. That will cancel. And the only surviving terms will be these two. As expected, they both have h's in them. Okay? Third, f of x plus h minus f of x over h equals this stuff over h. We're going to divide each of these terms by h. So 70hx divided by h, the h's would cancel, leaving me 70x. The 35 would be unaffected. H squared divided by h would leave me h to the first. Okay? Fourth. Okay, step 4. And not before. H equals 0. So we have 70x plus 35 times 0. 70x plus 0 is 70x. Okay? And that is how this would be done. Okay? Now, going back to this step, some people would need to see this. They would go ahead and factor out the h. Let me see if there's any way this could be fit in. They'd factor an h out of here. And then they cancel off the h. Okay, h squared, factor out the h without leaving h in there. Some people need to see that, that's fine. And this is where I will stop.